Moments ago at 0317 UTC, declassified fragments of telemetry from a long-buried space mission resurfaced in an unexpected place, and not through an official press conference, not through a scientific journal, but through a quiet data reconciliation error inside an archival server. Earlier today, analysts noticed something that should not exist in the historical record of human spaceflight. For the first time in recorded history, a United States space mission from 1990 appears to have returned to Earth carrying anomalous mass, unaccounted for at launch. The timestamps are precise, the orbits are verified, the numbers are undeniable. And if this data is accurate, then everything we thought we knew about one classified flight must be reconsidered. If you want real-time updates on unfolding cosmic mysteries like this, subscribe now, because what you are about to hear was never meant to be discussed. The mission in question was officially described as routine, conducted under the authority of NASA, with oversight from the United States Department of Defense. It launched at a time when the Cold War had supposedly ended, yet secrecy in orbit had not. Publicly, the flight was framed as a standard orbital deployment operation. Privately, it was placed under one of the highest classification levels available to the US government. Scientists from partner institutions were excluded. International observers were denied orbital parameters. Even within mission control, compartmentalization was enforced. Data was verified not once, but 6 times, across independent systems in North America and Europe. Radar tracking from civilian observatories matched military telemetry. There was no launch anomaly, no declared malfunction. And yet, from the moment the spacecraft reached low Earth orbit, something began to diverge from expectation. 72 hours before detection, ground-based radar arrays noticed subtle inconsistencies in the spacecraft's reflected signature. Not enough to raise alarms at first. 11 hours later, infrared sensors recorded localized thermal fluctuations near the cargo bay, inconsistent with passive equipment. At T-4 minutes before a scheduled orbital maneuver, onboard instruments registered a transient electromagnetic spike measuring 18 nanotesla, a value small by cosmic standards, but impossible within the controlled environment of a shuttle payload bay. Engineers assumed interference. They always do, but this time the interference did not repeat randomly. It synchronized. The spacecraft was Space Shuttle Atlantis, flying a mission that would later be designated as one of the most classified shuttle flights in history. Its crew was trained for silence, not storytelling. Communication transcripts from that week remain heavily redacted. However, what has recently emerged is not testimony. It is physics. Precise mass measurements taken during re-entry preparations indicated an increase of approximately 74 kilograms compared to launch values. Fuel logs showed no discrepancy. Life support consumption was nominal. No debris capture was reported. There is no known mechanism by which a sealed spacecraft gains mass in orbit. At first, investigators proposed conventional explanations: thermal expansion, sensor drift, calibration errors induced by radiation exposure. Teams at Caltech ran simulations to replicate the readings. They failed. Engineers working with archived data from ESA compared the anomaly against known shuttle missions. No parallels were found. A classified review board quietly escalated the issue. The data was real. Redundant systems agreed. Whatever changed the shuttle's mass was external and undocumented. Then came the trajectory anomaly. Approximately 11 hours before deorbit burn, the shuttle experienced a micro-adjustment in velocity, 0.4 meters per second. Too small for crew to feel, too precise to be atmospheric drag. No thrusters fired, yet the craft corrected itself, not randomly but efficiently, conserving angular momentum in a way that suggested active compensation. No known natural process could explain this. The laws of orbital mechanics allow only so many excuses. At this point, a small group of astrophysicists and defense analysts were brought in under emergency clearance. One of them, Dr. Elaine Mercer, an orbital dynamics specialist affiliated with a defense-funded research institute, proposed the first theory: an undocumented micro-debris capture combined with structural flexing. It was conservative, safe, incomplete. Another researcher, Dr. Rajiv Malhotra, suggested something far less comfortable: that the shuttle had interacted with an object possessing its own internal energy distribution. Not debris, not ice. Something structured. Spectral analysis of residual radiation inside the payload bay revealed narrowband emissions clustered around 142 Gz, the hydrogen line, a frequency so fundamental that astronomers use it to map the galaxy. Its presence inside a human spacecraft was inexplicable. Simulations attempting to reproduce the signal required assumptions that violated known material science. The debate intensified. Two explanations emerged. One insisted this was an exotic but natural interaction, perhaps an unmodeled plasma phenomenon. The other suggested unknown physics, or worse, intentional design. Everything changed when the shuttle landed. Post-landing inspections at Edwards Air Force Base detected localized magnetic anomalies along the interior bulkhead of the cargo bay. Tools behaved unpredictably. Compass needles drifted. More disturbing was what engineers found when they weighed removable components. The excess mass was no longer distributed evenly. It had consolidated, as if something had settled. No public announcement was made. Instead, the mission was classified retroactively. Crew members were reassigned. Data was sealed. Even within United States Air Force archives, access required justification. Officially, the mission returned successfully. Unofficially, it returned changed. In the weeks that followed, satellites in similar orbital inclinations experienced brief communication dropouts. Not failures, delays. Signals arrived milliseconds late, as if space itself had thickened. Migratory birds altered routes. Ground-based magnetometers recorded faint, rhythmic oscillations. No panic ensued. Only meetings, closed-door briefings, encrypted calls. Years later, fragments of the Anomaly resurfaced during AI-driven archival reviews. Pattern recognition algorithms flagged the hydrogen line emissions as non-random. Prime number spacing, mathematical elegance. This was no longer noise. It was structure, and structure implies intent. Perhaps this was not an invasion. Perhaps it was not even contact. Perhaps it was a hitchhiker, something that noticed us noticing it. A passive intelligence drawn not to Earth, but to our machines, our movement through space, our sudden noisy presence in a once quiet orbital environment. The universe has always watched us from afar, but in 1990, for the first time, something may have watched us from inside our own spacecraft. The final data point remains unexplained. During long-term storage, one sealed component from the shuttle continued to emit a decaying electromagnetic signature for 11 years. No power source, no known decay curve. Then abruptly it stopped. This story is still unfolding. The data is incomplete. The implications are vast, and the question remains unanswered. When that shuttle returned from space, did it really come back alone? Subscribe to stay ahead of the next discovery.